She just wanted to hear you say that again.
So start eating with your eyes. Don't eat while driving or watching television or doing anything that isn't totally pleasurable and all centered around food. It is why food has been a social occasion for every culture in every part of this world. And we so got away from actually paying attention to food and conducting our social business that food has been incidental. It's just something we do without even thinking about it. So the body then is totally unprepared for what's coming. So eat with your food. Eat with your eyes. And then open your mouth and chew. And take a bite and actually chew. Don't do the, what I call MAD, meaning the modern American diet. Chomp, chomp, swallow. Chomp, chomp, swallow. Chomp, chomp, swallow. Just get it in there as fast as you can. Because your teeth mix your saliva with the food. And saliva immediately begins to break down what in the mouth? Carbs. Sugars. And these are our energy units. So if our saliva doesn't already start pre-digesting your sugars, by the time the food gets into the stomach, it's going to have to do that part of the job, which means now it has to take a step backward because it needs the energy or those carbohydrate units in order to be able to go forward with the digestion process. So thoroughly chewing our food, 15 bites for soft food, 30 bites for harder or heavier foods, is a good rule of thumb.
Wow.
And if you have to count, yeah. What the basis of digestion is turning everything into fluid, which is why when you do juicing, it's easier to digest. So the more you chew and the more you liquefy your food, then the easier all the nutrients are absorbed. The less hydrochloric acid you need, the less biles you need, the less enzymes you need, and the less stress on all of your digestive organs. So chewing food is a very important part of digestion. And getting those sugars activated right in the mouth, so by the time the food gets to the stomach, it's all ready to go. And food doesn't have to stay in the stomach more than about 10 or 15 minutes. Otherwise, food can stay in your stomach up to 4 to 6 hours. Same food, just chewed differently.
That doesn't mean you get hungrier quicker or anything like that. It just
It can. It can.
But it should digest as soon as how long? 1 to 2?
Ideally, you want the food to leave the stomach in about 15 to 20 minutes.
Leave the stomach,
Go into the small intestines.
works.
15. So once you've chewed your food properly, it's going to go down the esophagus or the food pipe. So this is esophagus. And I'm greatly foreshortening that because it's fairly long. And at the bottom of the esophagus is a valve. It's called the cardiac valve. And then it goes into the stomach. And there's another valve at the bottom of the stomach, and this is called the pyloric valve. So the human stomach is kind of divided into half, even though we only have one stomach, as opposed to cows, which have 4. Which is why we and cows digest things differently. So when the food comes down the esophagus, nicely chewed, of course, as it passes through the upper part of the stomach, it gets sprayed by a little shower of hydrochloric acid. And this is where the intelligence of both the eyes in preparing this hydrochloric acid and the amount of chews are going to tell the body how much spraying of hydrochloric acid needs to happen here. So literally, it's a little shower on its way down to the bottom of the stomach. Now, if you've chewed properly, this is going to be really soupy. This is going to be a lot of fluid down there, which is exactly what you want. And a little bit of hydrochloric acid will get injected into this soupy mash, and your stomach will, literally, it's a big muscle. It'll churn it, mix the hydrochloric acid in, which becomes a tenderizer for your food. So that breaks the food down to the next level where proteins can get digested. And once it's very soupy, and it's now called chyme, then the stomach releases this into the small intestines. So this first part of the small intestines is called the duodenum. It's still the small intestines, and there's no valves here. The goal of the duodenum is to take all the food that was in the stomach so that it can dump, this valve can open, and everything can dump here, and then it will gently squeeze it in small doses into the small intestines, of which we have around 27 feet. And inside these small intestines, we have two main things that are going on. These little finger-like appendages called villi, and in between them, little tiny hairs called cilia. So we have villi and cilia. And if you picture the bottom of the ocean where all of that grass and other stuff is, it's always moving.
Yeah.
Yes. And its job literally is to keep things moving because it's really liquidy. You don't have to have big muscle action here. You just need these nice little things to keep it moving along. And they serve another purpose. Literally in between the villi and the cilia, this is a culture where probiotic microbes are made and where flora and fauna live. And a perfect, under ideal circumstances, a perfect pH balance is maintained. Not too acid, not too alkaline. And literally the nutrients now, which have been well broken down with the saliva and the hydrochloric acid, and a few other things we'll talk about in a minute, are ready now to be assimilated through the walls of the small intestine. So what nutrients literally do is they can stick to the little hairs, the little cilia, which work their way down to the base of the small intestine wall and move through the wall where they're picked up by blood. Isn't that fascinating? So literally 85% of nutrients is absorbed in this 27 feet of small intestines, and actually the bulk of it in the first half. So picture all kinds of fats and vitamins and minerals and sugars and proteins and everything that the human body needs coming through the walls of the small intestines to be picked up by blood factors. Now this is where we need all those lovely platelets, because those are what carry stuff from the small intestines to the liver, which we'll get to in a second. Don't you wish you learned this in like elementary school?
Why not?
We would have thought of eating in a whole different way.
I actually did learn this in elementary school.
Yeah, well, you went to a good school.
Where'd you go?
Minnesota.
I never learned it.
I actually, at university, I remember I took a graduate level holistic healing class where we brought in all these practitioners of every different.
Very nice.
Yeah, and there was one lady who actually talked about manual peristalsis. Have you ever heard of that?
I have.
Yeah, it was crazy. Like you actually like assist digesting, like by using your hand and actually going along the digestive tract and moving the food along. It was crazy.
but
So,
sometimes necessary.
I guess, especially if you don't chew enough, which I
And
don't.
if you eat wrong food.
Yeah.
If you eat wrong food. Okay, so we're looking at the fact that 85% of the nutrients of everything that we eat go through the walls of the small intestine. Okay, so I'm gonna, first of all, go through the whole digestion as if everything is just perfect. And then we'll go through when it's not.
Really?
Okay, mostly.
Two times.
Okay, so by the time then this food gets distributed and it works its way through the small intestines, and we have all kinds of really great nutrition coming out, getting picked up in the blood. Body's really happy because it's got all this good stuff. It's got new fuel, it's got new nutrients, oxygen, all kinds of cool stuff. By the time it gets down to the end of the small intestine, it is really fluid. Most of anything that is filterable is gone. And now we come to a big transition, probably the biggest transition of everything in the human body. And that is the transition of what goes from the small intestine to the colon. So I'm going to do a little bit of erasing so we don't get too bogged down here, because this does get really long. Okay, so this is the ascending colon, the transverse colon, the descending colon, the sigmoid, and the anus. So the biggest transition happens right here. This valve right here is called the ileocecal valve. And this is a one-way only valve. All the other valves so far, stuff can go up or down, in or out. Not this one. One way only. Meaning, only stuff comes from the small intestine into the colon. And what keeps this particular valve right here strong and functional, tightly closed at all times except when it needs to open and then close again quickly, is a very little known mineral called manganese.
Ah, that's what the strawberry leaf comes in.
Yeah.
Nice.
So what is the thing that depletes manganese from the human body faster than anything else? Refined sugar. Depletes manganese. So this valve right here, if it gets weak and it can't stay closed, then the flora and the fauna and the microbes and everything else that's in the colon gets backwashed into the small intestine. This is a problem. We'll talk about that in a few minutes. It's not good. It's not. Not good at all.
It's not a good problem to have.
Not a good problem to have. Okay, so let's say this ileocecal valve is working just great. We've got a backup of stuff that's ready to come into the colon. This valve says, all right, is everybody ready? We're gonna open, then we're gonna close really fast. And we gotta do it in such great timing that everything from here to here gets emptied in there, we gotta close it right out. 1, 2, 3, go. And that's what happens, literally. It's a perfectly timed thing. And as soon as this valve opens and everything comes in and begins to fill up the small intestine, the large intestine, that valve closes very tightly, and then something else magical happens. This other funny little appendage that's called the appendix. Now, modern science is kind of coming to the conclusion that, okay, this might actually have a function in the body. So I'm here to tell you what that is. The appendix is the immune system for the colon. It produces a particular white blood cell that is only found in the colon because this can be the most toxic place in the human body. So it has to have its own immune system to take care of the particular kind of toxins that happen in the colon. It's so important that there is a single herb specifically for the appendix, and it's called red raspberry leaf.
So when people get appendicitis, is that?
Problem. Now, when we do the downside of this, we'll go into that.
Okay.
So right now, you're just learning what it's for and what
Got
its
it.
function is.
What does it do again?
It's the immune system for the colon. It makes particular white blood cells which clean up the toxins that are particular to this area of the body. And it also produces the wherewithal for the large intestine to make its own particular kind of probiotic microbes. Now, the particular probiotic microbe that lives in the colon is called Candida. So this is a natural place for Candida to live. If it gets out of the colon, problem. So what does Candida primarily do? It and a few other microbes separate fluid from fiber. And they do it through a particular process of fermentation, where it begins to ferment certain kinds of proteins. It ferments certain kinds of dairy. It ferments a whole gamut of these bulky fibers so that all the fluid can be extracted from them. Another natural place for this to occur is in the mouth, the ears, and the vagina. These are natural places for Candida to live. But they must be kept in balance at all times. If ever they get out of balance, you've got a problem. So what helps keep these in balance is the appendix and the particular factors that it makes for the colon.
So the appendix, it's the immune system for the colon?
Yes, it is. And it also has a little opening from the appendix into, if this were a cross section, into the large intestine. And its valve opens when it's ready to excrete all of its properties and closes. So if something should ever backwash into the appendix, that's a problem.
That's why they get appendicitis.
So the appendix makes Candida, basically, or is
It
Candida
makes
just something that's present?
the pre-probiotics.
I was
So
gonna
the
say-
colon can make Candida.
Well, yeah, I was gonna say, like, if modern science hasn't seen the purpose of the appendix, but yet Candida is a term that is a definition that exists, how can they not acknowledge the fact that?
Because it doesn't actually manufacture Candida.
So it
It's like-
basically is a support organ that is creating a lot of things that allow that to be made.
Correct.
How do they not know that? You know that.
Because all they are looking at is dead bodies. And in a dead body, the appendix does absolutely nothing. You can culture it all day long and you won't find anything that actually appears anyplace else in the body. So how do I know that? I talk to appendixes. It's that easy. And it's one of those voodoo witch doctor answers, which I'll take full credit for. Okay, so we've got an appendix and we've got a valve for the appendix. We've got the small intestine and a valve, that there's a valve between the two. And we've got the colon. And look how much happens right here in this very small amount of real estate. And what happens here will determine whether or not you live or die. And if you take away one of those, whether you live or die now is going to be determined by that little guy right there. Wow. It's that important.
Is that where, is maple syrup, maple base syrup good for that valve?
It's very good for that valve.
Okay, I read that somewhere.
It helps that valve to reabsorb manganese.
And the distribution of the oils, where that happens?
In the small intestines. All nutrients, 85% are better.